Here
we go. Let's get into it. So, like I said, laundry list of types of factor. Now, it's a little overwhelming when you first look at this, but you honestly have done all of this a million times. We're just going to refresh your memories. Because like I said, all of a sudden you'll be in a chapter, nothing to do with factoring, but it just like hits you in the face. You got to be able to factor on one of the problems to solve it or something. So that's why we cover this first. So we're going to start with greatest common factor. Easy, that's the first type of factor you learn. How to factor difference of squares, like that one too, that's not too bad. Trinomials, 3 terms, leave coefficient 1, and then not 1. Grouping, if you remember, that's your 4 terms, or you're going to split it in the middle. And then factor completely, that's where it's a free-for-all, and you can use any method you would like, and you may have to factor more than once. So like I said, we're not going to do all of it today. We're going to kind of tackle the first half and do the rest of it tomorrow. Now, you'll always see I kind of put some, looks rando, really not rando, some warm-up problems on here just to kind of, I know what's coming at us, just to kind of practice and review and answer any questions we might have. So simplify the following. So we don't want a decimal, we want them square root style. So there's 2 ways to simplify square roots. You can either make a factor tree, that's my least favorite way because it's time consuming, or think about the biggest perfect square that divides into them. So when I'm thinking perfect squares, I'm just going to make a list on the side, like 1 squared, 2 squared, 3 squared, 4 squared, 5 squared. I mean, I could do this all day. Nobody wants to watch that. So I'm looking at A. What's the biggest perfect square that goes into 8? 4. So I'm thinking, okay, I'm going to rewrite this as 4 times 2. 4 times 2 is 8, of course. Square root of 4, nice and easy. 2. And then the 2 stays underneath. So 2 square roots of 2. So I'm assuming you've probably done this before. Just need a little refresher. Okay, 75. Biggest perfect square on our list that goes into 75, 25. So I'm going to rewrite this as 25 times, how many times is 25 going to 75? 3. I know this is riveting stuff. I love the beginning of the year sarcasm. What's the square root of 25? So 5 square roots of 3, got it. Ooh, fancy on C. I put a 3 in the front. Ooh, okay. All right, so this, of course, just remember means times, my dramatic times symbol there. Now I'm going to do the same thing. I'm going to start with the square root of 50. Clearly, the biggest perfect square that goes into 50, 25, goes into there 2 times. Now, a lot of you, I'm guessing, I hope, can go straight to the answer right now, and you can skip this next line of work. I'm going to write it just for the love of math. Square root of 25, of course, 5. Now, personally, I probably would have skipped that line because I would just mental math it. What's 3 times 5? 15. So we have 15 square roots of 2. Again, I probably usually, like all math teachers, show a little more work than you may do. That's totally fine, okay? All right, 48. What is the biggest perfect square that goes into 48? Mental math. 16. 16 goes into it how many times? 3 times. Are we going to have to get out the flashcards, kids? Okay. Now, let's go straight to the answer. That would actually be kind of entertaining. What's the square root of 16? 4 times 4. Final answer. 16. Got it. So, like I said, we're not simplifying radicals today, but it is going to start coming up in quadratic formula. So just kind of prepping us for that, always prepping us for what's coming up in the future. Okay, easy peasy today, my friends. Factor out the greatest common factor for the following. Like I said, I am 100% sure I'm not teaching you anything new here today. So I'm looking at all 3 terms. Now, let's start with the number. 4, 12, 4. They at least all have a 4 in them. Now, you could use positive 4 or negative 4. It doesn't matter. It's your pick. I don't know. I'm feeling fancy. I'm going to go negative 4. Then I'm going to look at the variables. N cubed, n squared, n. They at least all have an n, a single n in them. So that's going to act like your distributor. That's your greatest common factor. So to get my original term back, I took the negative 4, I took out an n, I need an n squared. That will make my n cubed. Watch your sign here, careful. Negative 4 times what gives you back positive 12? Negative 3. We took an n out already. We need uno más. Didn't know I knew Spanish, did you? A little bit. Okay, final. Negative 4n times what? We do need something here. Gives you negative 4n. 1. We need the placeholder of 1. Because, of course, if I don't have the 1, when I distribute, I won't get everything back. Now, I'm going to circle that in a minute. You could, again, multiple ways to write it. Let's say you just use positive 4n. Fine. That, of course, just changes the signs on everything inside. Do I care which you use? No, I sure don't. I'm going to circle both, okay? All right, B. What's your greatest common factor for 90, 50, 20? They at least all have how much in them? 10. N to the 5th, n cubed, n squared. They each have a minimum of n squared. So now I'm just going to go through and figure out what we need here. To get to 90, 10 times 9 is 90. We have n squared, we need 3 more to get to a 5. Okay, 10 times 5 is 50. I took an n squared out, uno n, and of course 2 to hold the place. And I'm pretty sure I've taught you nothing new, right? Yay, okay, trust me, the whole year is not this easy. Don't get your hopes up. All right, factor the difference of perfect squares. Now, difference, of course, subtraction, so that's why there's minus in them. And notice everything up here is a perfect square. 16 is a perfect square, 25. N squared is a perfect square. So these are my favorite. They're super easy. They always factor out into 2 binomials, 2 terms. Now, 16 perfect square, of course, to get that, I need 4 and 4. So my first term in each of these, 4m, 4m. 25 perfect square, 5 and 5. Now, here's what you got to know are the signs. Are the signs both plus, both minus, or one of each? One of each, because positive, negative gives you the negative. Doesn't matter if you do plus, minus, minus, plus, whatever. Got it. Okay, 25b squared minus 4. No work, let's just do it. To get 25, of course, 5. 5b, 5b. Oh, man, that's some rain. To get 4, 2 and 2. And you guys already told me, one of each, plus, minus. Okay, questions on that? I'm assuming that's too easy. All right, next up. Factor each trinomial, lead coefficient 1. Let's scroll this up just a little bit. So 1, of course, 1r squared, 1x squared, 1x squared. So this is where you have to be good at your times tables. You're playing that little number game, so to speak. What multiplies to the last number and adds to the middle? I know the times tables. So what multiplies to negative 27 and adds to 6? 9 and negative 3. So one of the factors are plus 9. The other r minus 9. Or r minus 3, sorry, r minus 3. We said 3. And it doesn't matter if you have the r minus 3 first, the r plus 9 second. You get the same thing. Order you multiply, it doesn't matter. All right, let's do B. This is easy. Multiply to 35, add to 12. 7 and 5. Got it. Okay. Multiply to 18, add to negative 11. Negative 2 and, yeah. Got it. All right, so look it over so far. Any questions I can answer? Have I taught you anything new yet? I figured not. Okay, that's as far as we're going today, my friends. We're going to do the trinomials, not one tomorrow, the grouping, all the other stuff tomorrow. So I do have a lovely worksheet for you.